Hey boys and girls, welcome back to another day of Number Corner. It is Thursday, February the 25th, and I can't believe February is almost over. I just feel like it went by very quickly. We are going to look at today's calendar marker very quickly. We will update our calendar collector, and then we're going to play Put It on the Line again. Look at today's calendar marker. How many line segments do we have? Yeah, we have 3. And if I were to describe the angles here, what could I say about them? We know we have one acute angle from yesterday. What about this angle right here? And I'm actually going to pull it up on the calendar so that we can see it maybe a little more clearly. And then maybe I can draw on it to help you. Because it's hard for Miss Trammell to show you how to use a protractor virtually, but I can talk with you about using benchmarks when you're trying to figure out the size of an angle. And that's exactly what we're going to do for today's calendar marker. We're going to use a benchmark to figure out whether or not it is acute or if it is a obtuse angle. Or is it a right angle? So let's zoom in. Here's the 25th. And let me draw on this. I'm actually going to get a straight edge. We know that this was acute. We're trying to figure out this one right here. So if I wanted to create a straight line here, I have now created a 90-degree angle, about 90 degrees, which means that this whole angle right here is right, it's an obtuse angle. So I have like an acute angle and I have one obtuse angle. And that's just how I would name it. Okay, now let's look at our calendar collector. Let's spin for today. Right now we are at 256, I believe. And let's see what we're collecting. Just 1 degree. We are really close to 270 degrees, which is how much of a full rotation? What fractional part? It's a 3/4 of a full rotation. We're almost there, but we're not quite there yet. And it looks like, do you think we're going to make it all the way around the circle if we only have one more day? No, probably not, but we do have a strong chance of passing that 270 degree mark. So I will go ahead and write down that we are adding 1 degree, and so we now have 257, or I should say 257, not and 57. We know that and means a decimal, right? Right. Okay. Now on for today's main attraction, which is the game Put It on the Line. We played it last time, and if we were in person together, I would say, let's play it with a partner, but we're not. So that just gives us more time to practice together. So that's what we're going to do. Just to remind you of the rules is we are revealing a problem one at a time, and then whatever the answer is, we put that on the line where it belongs. So hopefully we know the sections that are in between 0 and 1. And then whoever has the combined highest total wins the game. So let's play. Last time you guys went first, and I'm going to allow you to go first again this time. So we're going to choose at random. I have no clue what's behind these cards. I did win last time. Let's see if you can win. Here we go. 6/10 minus 5/10. And then it says show the solution. So I could shade in 6/10, which is actually here. Let me see if I can zoom in even more, and I'll just make my face a little bit smaller. So I have 6/10, and I want to take away 5/10. What am I going to get? This is your question. Yeah, I have 6 of them here, and then I take away 5, and I'm just going to show that with an X over the 5/10. 1, 2, 3, 4, 5/10, and that leaves me with 1/10 left over. So where am I going to write 1/10? Right, in that very first marker. That is 1/10. I could even write that as a decimal, which would be 0.1, right? All right. Miss Trammell's turn. Let's see, what shall she choose? Maybe this one. 9/10 minus something gives me 3/10, which means I could do 9/10 minus 3/10, and that should also give me that something. 9/10, I take away some, and that leaves me with 3/10. How many am I taking away? I think that means I'm taking away 6/10. Because 9 minus 6 is 3. So I get 6/10. Yay! Go me. Go me. Game of chance, people. Game of chance. 6/10. I know halfway is here. So 6/10 must be right here. 7/10, 8/10, 9/10, 1 whole. Perfect. All right, your turn. Go here. Let's go here. If the large square is 1, what is the value of the shaded part? Count it up. Did you say 7/10? Good. 7/10. See, now you're beating me again. So 7/10 goes next to 6/10. 7/10 is greater than 6/10. Nice job. Miss Trammell's turn. Let me go in this corner. 1/5. Show the solution here. 1/5. That means I need to separate. I almost made a mistake, guys. I almost colored in 1, and then I was like, but it can't be because you guys already had 1/10. Then I realized it's a 1/5, which is 20 cents. Remember our problem string yesterday where we related it to money? So I could separate my shape here into 5 groups. And if I shade one of those groups, then I would get 2/10. And I know that 2/10 is equivalent to 1/5. Very good. 2 nickels versus 1 dime. Or not 2 nickels, excuse me, 20 cents. So 4 nickels versus 2 dimes. All right. Your turn. Where are we going? Here? Let's see. Henry found 3 dimes between the couch pillows when he was cleaning. What fraction of a dollar is this? 3 dimes. Good. 3/10. Awesome job. Or I could even say 30 hundredths. 30 hundredths. Miss Trammell's going here. If the large square is 1, what is the value of the shaded part? Oh, that's easy. I hope you guys know this as quickly as I know it. This is half. Half the whole thing. And half is like saying 50 cents or 5/10. So I get to put up 5/10. All right, who do we think is winning? Oops. Guess we got to keep playing. Okay, where do you guys want to go? Here? Let's try it. What is the decimal number that represents the shaded part of this pentagon? Ugh. So these are in fifths. 1/5, 2/5, 3/5, 4/5, 5/5. We got 4/5. If we look up here, 4/5 would be how many tenths? 8/10, and they're asking for the decimal, so I'm going to label that for you guys. It was your turn, right? Yes, it was. 8/10, and I will put it here, but I'm also going to write that as a fraction. 8/10. Oh, come on. Come on, Miss Trammell, you got to do this. Which one are you going to choose? Let's go here. What is the value of the 9 in 8 and 967 thousandths? Oh, do y'all know what place that's in? It's in the tenths place. Yes, so now I get to put up 9 tenths. Okay, now you guys, maybe this one. No! 10 times 1/10. What is it? Good. It is 10 tenths, which is 1 whole. And I'm not happy that you guys got the 1. I was really hoping to get it, but I didn't know where it was because I didn't look at the problems beforehand. That's only fair, right? So that means I'm stuck with this, which I already know what it's going to be because I only see 1 left over. But 1/10 plus 3/10. I will show my work for those of you who are still working on understanding adding of fractions. Here's 1/10, and then let me add 3/10 to it. So here's my 3/10, which means I have a total of 4/10, and I will add that to the line. While I'm adding that to the line, go ahead and figure out what your combined total is. What is your total? I'm going to figure out my total. Right, you can focus on the numerators since the denominators are all the same. So for me, I have 10, 15, or I could say 10, 20, 21, 26 tenths, which is the same thing as saying 2 and 6 tenths. That is my score. Have you figured out yours? I hope you have. You guys had 1/10 plus 3/10 plus 7/10, and I haven't figured it out, guys, yet, so I really don't know who won, but I'm still hoping that it was me, because you know I like to win. Okay, so 1/10, 3/10, 7/10, 8/10, 10/10. So here's 10, 20, 28. I already know I lost. You guys had 29 tenths, which is 2 and 9 tenths. So who won? You did. Good job. Thank you for sticking with me today. We have one more day in February before it's March. Can't believe it. We're almost there. Hang in there. You guys have a great afternoon, morning, day, whatever time it is for you. And I'll see you tomorrow.